given the magnitude and direction of the net, give the magnitude and direction of the net force acting on the following scenarios. So it's time for you guys to okay, a drop of rain falling with a constant speed, a cork floating, a kite stationary, constant velocity, high speed, velocity with free of, those are the keywords. So with all of these keywords, I can give you guys one answer, that the acceleration will be 0, right? So if the acceleration is 0, from this what can we infer? The net force will be 0. Reason being constant speed. Reason being cork floating. Okay, so if something is floating, right, imagine you have a bucket of water and you have something floating over there. There's no movement, no nothing. This is a case wherein you have gravitational force pulling down. At the same time, you have the buoyancy force pushing it up. Buoyant force, I hope you guys remember, it's common sense actually. Buoyant force you get to see almost every day, directly, indirectly. You can observe it. So this is your force because of gravity. So these two will cancel each other out. So the net force is 0. Kite stationary. So same thing again. Kite stationary means gravity is pulling it down. Instead of buoyant force of water, there will be buoyant force of air basically. Air is pushing it up. Actually, not technically, it's a wind. Sorry, that won't be air. It's not buoyant force. It will be wind that will be pushing it up. Car with a constant velocity. So let me talk about C. So we have kite. Kite will be getting pulled down because of gravity, but the wind force is keeping it stationary. So they are equal in magnitude but opposite in direction. When it comes to D, constant. So we have the force because of friction that is moving to the, it will be right if the vehicle is moving to the right. The force of friction will be to the left. Okay, there is a lot of things that I can't explain now. But point is, your vehicle engine is pushing it forward while the friction is trying to pull it back. When these two are equal, that's when we get constant velocity. An electron. So you guys, if you guys vaguely remember, electrons are negatively charged. So they're charged particle. When they're moving, it is current. I hope you guys remember all of that. Moving charges are current. So electrical current, that is. So they create magnetic field and electrical field and so on and so forth. But there is no other force to interact with because that space is free of electrical and magnetic field. And so that will experience no force. Now the moving electron experiences no force. So this is a good question for you guys to, instead of it being a question, you can make a note of it. So all this can be directly, indirectly asked as MCQs in terms of inertia, in terms of indirect questions. They might ask you to find out the force, net force, maybe not net force, but the other force. So this can come any point of time from now to your 12th grade exams. Actually, everything can come. But yeah, specifically this, you need to have a sense of this. This should be commonsensical to you guys. It's like 1 plus 1. So this is a 1 plus 1 set of points.